we're going to take a look at angle of elevation and depression. We have two questions. Let's get to it one time. So question one tells us, a kite has a string 150 meters long. The string nailed into the grass makes an angle of elevation of 41 degrees from the grass. That's an important point. They want you to draw a diagram to represent the information above and find the height of the kite above the ground. Now, when you draw a diagram, you'll get a right angle triangle. All right, so from this information here, you would obtain a right angle triangle. All right, and from the right angle triangle, you'll be able to find out the height. All right, when you label your diagram properly, you'll get your height. So let's deal with it one time. So they said a kite has a string 150 meters long. Good, note that. The string nailed into the grass. So this is, all right, there's the nail into the grass. All right, there's the nail. This is the string, and they said the string is 150 meters long. Right, a little better than that. Right, they said the string is nailed into the grass, makes an angle of elevation of 41 degrees. Now, the angle of elevation is from the string that is nailed into the grass. So it's from this point. So when you are talking about the angle of elevation from this point, which is where the nail is located, you must draw your horizontal line first. After you draw your horizontal line, then you put your arrow up indicating angle of elevation. So this is your horizontal line from the nail. This is your horizontal line. Once you have that, you indicate, okay, angle of elevation from the horizontal going up. This is your angle of elevation, and this is 41 degrees, right? 41 degrees. So as I said before, it's a right angle triangle, so you just close your triangle. Right. Just close your triangle. This is your right angle triangle happening right here, 90 degrees. 90 degrees. So this here represents the diagram, all right? This is part A, this represents the diagram. Let me make sure I'm not missing anything. We have 150, we have 41, nice. We have our triangle right here. Part B asks us to find the height of the kite above the ground. Now, this is the kite. All right, just do a little illustration here. There's the kite. We want to know what is the height of the kite above the ground. So we want to find out what is each. So we have to label our diagram. So with labeling our diagram, right, from the acute angle straight across, this is the opposite, right? This is the 90 degrees pointing to here. This is the hypotenuse. And this is the adjacent side. You all can check out my video on trigonometric ratios. All right, so I went into detail as it relates to finding out what is the height or what is the opposite, hypotenuse or adjacent. All right, so check out my trigonometric ratio videos, unknown side and unknown angles. All right, so we take the side that we have. So we have this side and we need to find out that side. So SOHCAHTOA just helps us to choose the correct ratio, help us to remember the formulas. So we have O and H here. Here we have H, we don't have O. Here we have O, we don't have H. So we have O and H here. So sine theta is equal to opposite over hypotenuse. Sine theta is equal to opposite over hypotenuse. So now we substitute. Sine 41 degrees is equal to opposite, which is each, hypotenuse, which is 150. Each is equal to 150 multiplied by sine 41 degrees right? If you're wondering how I got that, I multiply both sides by 150. This will cancel out with that. All right, continuing, we make sure our calculator is on degrees, right? So we put 150 multiply by sine 41, and you get 98.41 to 2 decimal places. Write a little better than that. 98.41 to 2 dp. And that is in meters to 2 decimal places, 98.41. So that is the answer for number 1. This is part E, and I would say this here is part B, part A, part B. Continuing. Let's look at this question here. So this question states, okay, from an airplane at an altitude of 1,200 meters, the angle of depression, right? So this is important. Okay, angle of depression from what is the object? Airplane. Keep that in mind. The angle of depression from the airplane to a rock on the ground measures 28 degrees. All right. So you want to draw a diagram, find the distance from the plane to the rock. So that's important. Find the distance from the plane to the rock. Let's leave it at that. So the first thing, from an airplane at an altitude of 1,200 meters. So that's all right. This is my airplane, and they said altitude or height is 1,200 meters, right? So if there's the altitude, there's the airplane, well, there's the ground below here, so I'll deal with that one time. All right, there's the ground below here. Continuing, they said the angle of depression from the airplane. So we know from here we're talking about to a rock on the ground measures 28 degrees. So once you know the angle of depression from what? The airplane, you draw a horizontal first. All right, so you draw a horizontal first. So your angle of depression from the airplane. So from the airplane, you draw a horizontal. Right, and from your horizontal, we know the angle of depression is going down 28 degrees. All right, so this is our angle of depression, and that is 28 degrees. Right, so the angle of depression from the airplane, so you must draw your horizontal first, and then you deal with the angle of depression, which is a downward movement because you're looking downwards, and that is 28 degrees. And you complete your triangle. So here we have 90 degrees marking here. All right. Since here is 28 degrees, here will be 28 degrees as well, alternating angles. Here's 28, here's 28 degrees, alternating angles. Let me write that 28 a little better than that, right? So right here, we have our right angle triangle. We have our 1,200 altitude. We have our angle of depression here, alternating angles because these two lines are parallel. These two lines are horizontal, right? So if this is 28 degrees, this is 28 degrees, I simply tell students, look for the Z shape. This angle is equal to that angle, all right? The Z could be forward or back to front. So this angle is equal to this angle. Let's say forward. If the Z is back to front, this angle is equal to this angle. Bear that in mind. So that's part 1 or part E. So this is part E. Let's take a look at part B now. So part B is easy. Once you know part A, part B is easy. Assuming you went through trigonometric ratios, finding the unknown angle, finding the unknown side, this is easy. Part E just tells you to draw the diagram. So angle of elevation and depression is just a situation that is given to you where you have to draw a right angle triangle. And once you draw a right angle triangle, depends on what they give you, you can use trigonometric ratio to find out the specific length, or you can use Pythagoras theorem. So it just depends on what they give you. when you label the diagram. So part B, they want to find out what is the distance from the plane to the rock. So this is the rock on the ground, right? Because they said from the plane, angle of depression is 28, right? The angle of depression from a plane to a rock. So there's a rock on the ground, 28 degrees. So we want to find what is the distance from the plane to the rock. So we want to find out what is D, this distance here. So we have to label our triangle from the acute angle. This is opposite. Right angle, where the right angle is pointing to. This is hypotenuse. This is adjacent. So take this side we have. So we have the opposite. We have to find out the hypotenuse. So we're looking for a trig ratio with opposite and hypotenuse. So same thing. So we have opposite and hypotenuse. So we are choosing sine. All right. So we're choosing sine. Substitute it now. All right. So sine 28 degrees is 1200 over D. As I said, take a look at my trigonometric ratio videos, unknown angles, unknown sides, to look at this step in depth. I'm not going to go into too much detail. All right. So D multiplied by sine 28 degrees is equal to 1200. Remember, we need to find out what D is. So D is simply equals to 1200 over sine 28 degrees. And put that in a calculator. 1200 divided by sine 28 degrees. Make sure your calculator is in degrees. All right, make sure 1200 divided by sine 28. You will get 2556.07. So two decimal places, and this is meters. 2556.07 to two decimal places, and you must put a unit. Now, the two questions, right? The question didn't tell you to put it to the nearest meter or to two decimal places, two significant figures. So they didn't give you a specification, all right, for both of them. So if they didn't give you a specification, then you can choose. You can choose whether you want to put it to the nearest meter, two decimal places, three significant figures. You can choose, right? Something that is easy for you to do. So that's it for angle of elevation and depression.